if you remember in Java, you would call the super, use the keyword super to refer to the parent part and the child, right? So here we have something similar, but it's not identical. So we can use the keyword super, if you see it here, but as a function. So this preceded by parentheses like this, as if you are calling a function, and then you are calling the init of that super, of that parent. Okay? Now this is just a simple call or a call through an object. Okay? So this will give you a reference to the employee part of the object. So when you call a method of a class through the object, it is a message passing, right? So this is the object, and then this is a call to a method on that object. So automatically the self part will be populated by the object that you're using here before the dot. Okay, so if you use the keyword super, you only start sending arguments after the self. You don't need to send the self. Okay, because the self will be populated automatically by the object that we are using here before the dot. Yes.
Wait, what happens if you just put self?
Then the self will go to the name will go to the email will go to the salary. So you're shifting it. Okay? Because automatically when they call it, they send the self first and then you take the parameter sender next. Okay? Now if you call it through the class name like this, then that's just it doesn't send the first parameter, the self parameter did not send automatically. We will have to send it. Okay? So if you use the super, you're referring to the object, so you just call the method without the self. If you use the class name, then you need to send the self as well. So the value of this self will be sent as the first parameter here. Yes.
So the super like a pointer to the employee object?
Yes. Okay. So let's try to do that in both ways. So we'll try the first way first. So here I want to call the constructor of the employee using the class name. So if I use the class name employee dot, and then I'm gonna call the init method. Now in that case, I need to send it the self. I need to send it the pointer to the object. Now I don't define this pointer, I don't know its value, but it is automatically would be sent as the first parameter here. So I'm just gonna send the same value from here to there. Okay, and then we need to send the value that was received in the name as the name for the employee, and the value that received as the email for the email and the salary. Now the bonus is not part of the employee, so I don't need to send it here. Okay, what do I need? I need to initialize it in the manager object. You see here? So if we only receive name, email, and salary. Bonus is just part of the manager object. Okay, so I will initialize it outside of that employee.init. So I would say self.bonus equals bonus that was received in the file. All right. Now, when we get to define an object of type manager, so I just prepare a reference, and then equal, and then the class name, and then inside the parentheses, I start populating the parameters starting from the second. So name. So let's say Alice. Email. Alice at gmail.com. And salary. So let's say 1,000. Now there is another parameter that I can send or not. It's optional because there is a default value. So let's say I'm gonna say it's 400 to change the default. Okay. Sorry. All right. Now, if I see I only have the constructor or the manager. Now, if I try to print info, I can say m.print info. Now, see, I don't see it a method called imprint info here defined, right? But it is inherited from the parent. So if I try to run this code right before here to see what is going to be printed, you will see that it executed the function that is print info as defined in the parent. I can even try to step into it. So I'm gonna stop here and we'll step into it. So you see we are defined a manager object and we're calling a function called print info. And let's step inside of it and see what happens. So I'm gonna step inside. Now see, it goes to the definition in the employee class. And the name is Alice, the name, the email is correct and the salary is correct. Okay. Now what if I want a print info that also includes the bonus, right? There's some missing information here. So the implementation inside the manager doesn't have to match the implementation in the parent. Okay, and so in that case, we want to change it altogether. So I can use the overriding or the polymorphism. You remember that polymorphism? What is polymorphism? Yes. Change definition of a function, same function twice, same function name or definition twice, but the implementation was different from our process. I'm combining both for you, what you said. Okay. So we have the same. So polymorphism is multi pieces. Okay, so we have one function definition, the same name of the function, but the implementation inside that function would have a different code or different implementation in the parent than it is in the child. Okay, so I can redefine this function and have completely new implementation that is suitable to the parent. So now I'm just redefining what is printed. So here I'm just gonna say self.bonus. And you see, I'm not gonna change this line. I'm gonna keep it as it is. Now I'm gonna run it and see which one is gonna be executed now. I'm gonna step inside. Now the definition in the child is the one that will be executed. Okay? Because it is overriding. It kind of hides the implementation in the parent. The implementation in the parent still exists. I can access it if I needed to. But at this moment, I didn't access it, so it is completely hidden. Okay? So now it will print the information, including the bonus. Okay? Now there is another way to implement, another common way to benefit from overloading, which is to have slightly different implementation. So we don't want to rewrite the code in the parent, we just want to reuse it and make some small adjustment to it. Okay, so we don't want to access, we don't want to hide the implementation in the parent altogether. We want to access it and make some slight modification. So for example, the calc salary in the parent, in the manager, we need to add the bonus after we deduct the tax rate. Okay, so we don't want to rewrite this code. Okay, even it's one line because this is a simplistic example. Okay, you might have the implementation in the parent like 20 lines, 50 lines, 100 lines. You don't want to rewrite them. We want to reuse the code in the parent and then just add the bonus to it. Okay, so if we want to call the implementation in the parent, we can use the keyword super, the way that we had seen how it would look like in the constructor. So that would give us reference to the parent part or the employee part of the manager. And then I can call the calc salary from it. Okay. And then add my bonus too. Okay. So just to see how it would look like, I'm gonna put a breakpoint here in the definition in the parent, and then another one here in the definition in the child. Okay, now I'm gonna call m dot calc salary, calc net salary, and I will print it. Okay, now I'm gonna stop right before this point so that we just need to see what's happening in this line. So I'm gonna run this in debug mode. Now, missing requirement. Oh, so there is tax rate I need to send. So let's say tax rate is 1.3. Okay. All right, so you see, first hit here, the first breakpoint hit is the calc net salary in the child, in the manager, right? And then we're here, right before we return, we're gonna call the calculate salary from the parent. So if I just step, I made the same mistake here. So calc salary always needs the tax rate. All right, now let's try again. Okay, so here is the first call of the call for the definition in the parent, and then because we call the definition in the child, it will be executed first here. So remove the taxes and then adds the bonus and returns it. So what will be printed is just the tax minus, the salary minus the tax, and then eventually plus the bonus. Okay. Okay, so these are the main concepts in the object-oriented paradigm. Just quickly, we can try the other way. So instead of using the employee in the constructor like this, we can alternatively use the super keyword to refer to the object or the parent part of the object. So instead of using an employee, the class name, I'm going to use the super keyword. And now I'm calling this function through an object. And in that case, I don't need to send the reference to the object. It will be sent automatically. Okay, and that should give us the same behavior. Okay. Any questions about that? All right. So that is the object-oriented part.